Hello everyone, my name is Guilherme and today we will talk about using NLP++ to build a Brazilian address cleaner in HPCC systems. This project was implemented with the collaboration of David de Hilster, and this session will be followed by our academic partners at RV College of Engineering, so be sure to stick around. So I graduated with a Bachelor of Engineering in Computer Engineering in Brazil. I am a master's student in Management of Production Systems, and I am a software engineer at LexisNexis Risk Solutions. So it's just a quick introduction about me. So about this project, the objective is to build a Brazilian address analyzer and cleaner that can improve the current cleaning process with the benefit of being a transparent process with easy identification and correction of problems. So now we have to talk a little about address cleaner. What is an address cleaner? As the name implies, it's a tool that performs an address cleansing, which is the collective process of standardizing, correcting, and then validating a postal address. The address verification process includes multiple steps, such as parsing, which is the assignment of address elements into the appropriate fields. The second step would be the validation against postal data. The third step would be the formatting. So addresses are stricter according to international postal standards, in this case, the Brazil standard. The next step would be the transliteration. That is basically when data is converted. So is the conversion between non-Roman characters and Latin characters. And the last step is the address enrichments, which is when the tool provides additional information that helps you better understand and use the address data. So this is how an address cleaner works. And regarding common vulnerabilities, unfortunately, many people make mistakes when sharing their addresses. They don't use standard format, miss letters, forget zip codes, and much more. Some people may even enter the wrong addresses on purpose if they don't want to receive any marketing materials. As the input data is checked against a base of valid addresses, wrong addresses can generate unsatisfactory results, such as an address with bad formatting and fields assigned to the wrong places, or simply a match with an address that is different from the real one, due to a lack of specificity. For example, in ready-made tools and softwares, when problems like this arise, there's still the difficulty of finding the root of these bad results, basically being a black box. So why to use it, an address cleaner? To reduce errors and improve accuracy, to improve the data quality, and it fixes errors and corrects formatting issues. So the consequence is a positive impact on products and final user in several ways. So now let's talk about the protagonists of this presentation, the Brazilian address cleaner with NLP++. So at first, just like HTML or PHP, NLP++ is a text-based language. These code files can be edited with any text editor, but it is highly recommended that you use the VS Code NLP++, a language extension. And NLP++ is based on the fundamentals of trees. So, for example, if you ever diagrammed a sentence in school, NLP++ can do the same. Knowing the structure of language allows computers to know what words go together. There are noun phrases, verb phrases, prepositional phrases, and the like. NLP++ has data types and functions to create and use knowledge in a knowledge base called the conceptual grammar. Conceptual grammar is a hierarchical knowledge-based system capable of housing linguistic and conceptual information. Knowledge can be created, ingested into a system, and used to understand text. NLP++ analyzers also create knowledge directly from the text, which can be used to generate new knowledge and understand the very text it is processing. So the heart of matching is NLP++ rules. The syntax of NLP++ provides you with powerful functions and notations, allowing you to define what you need in order to process text. You can define the context to match, the pattern to match, build meaning with the rule, and then produce a new tree if desired. You can put any meaning to any rule at any time. Once a rule is matched, you can create new trees and at the same time label meaning on parts of the matched pattern. Another important part of NLP++ analyzers is their ability to make general rules. One of the great limitations with text analyzers is trying to make sense of the flow inside an analyzer, not with NLP++. Each file can embody a clear modular set of rules such as money, dates, companies, events, and output. Each text analyzer is made of a sequence of files containing the rules, or NLP++ language, and each file builds on the previous files, and you can see exactly what the analyzer has matched each step along the way. So NLP++ has some advantages over machine learning and neural networks, including that NLP++ can be developed on a small set of data using humans' ability to generalize. NLP++ can explain how you obtained its results, so it is like a glass box. There is no need of a large training data set, and it is easy to identify possible improvements in a NLP++ analyzer. And regarding the advantages over a human being, is that NLP++ has a reliable memory for large numbers of codes and terms and never tires as humans do because it is a computer. So about the materials used on this project, a sample with value addresses in Brazil and within the correct standard was used to develop our analyzer. Brazilian addresses are composed of the street name with an address type in the beginning, which is equivalent to an avenue, street, or highway, for example. The number of the place. If the address given is referent to a house, there is only one number to be informed, but if the place is an apartment, not only the number of the building must be present, as well as the number of the block, if there is one. The number of the floor in an apartment, the neighborhood, the city, the state, which must be informed by abbreviation, and the postal code. It is important to note that although there is a standard format for Brazilian addresses, some information is not required, such as the complement, that is the address line 2, which is used to inform the apartment where the person lives, for example. And as mentioned above, it is common for the address provided by a person to have flaws, such as typos or simply wrong information. Well, about dictionaries, dictionaries allows us to be clear by reinforcing the clarity of each word within the context of the larger phrase. And we use dictionaries to reinforce our natural language processing. Dictionaries can, therefore, be created for various sets of words. For this project, dictionaries were created for each part of an address and the possible values of address line 2, for example, for numbers, for Brazilian states and cities, and street types and names, for examples. So here we can see a few examples of dictionaries, and it's been common values used on these dictionaries during the construction of our analyzer. With the dictionaries created, it's time to create your rules and functions to identify the parts of a text. For example, here we can see the rule created to identify numbers in an address, which can be a postal code or a house number, for example. And the function then classifies the number as a zip code or not. Meanwhile, each step of a natural language processing can be analyzed, as seen in the image on the right, in which you can see the matched rules, in this case, the numbers. And here we can see highlighted that NLP++ shows which words matched with a rule. So we can see highlighted, for example, with the fired word on the image. As you can see with a few addresses, step by step, rule by rule, we keep incrementing the analyzer until we build a full address analyzer. With an address identified, the knowledge base can be built. With the help of the dictionaries also created, we can detect each part of an address and eliminate abbreviations or typos, for example. Now to integrate the analyzer created with HPCC, the created knowledge base is converted to a XML file because HPCC works really well with XML. The indentations in the XML serve as the nesting in the record, and thus all the information of an address can be converted to a record. With the results generated and addresses cleared, we can check the effectiveness of the analyzer. First, let's compare the input data with the output data from the current address cleaner. The fields highlighted in green indicate those that have been cleaned correctly by the cleaner, while the other fields have been assigned to the wrong field or have been fed to different values from those presented in the input data. Now, when we compare the results from address cleaner with NLP++, we see an increase in hits, and which are again the fields highlighted in green. And this was only possible because throughout the process, we were able to see possible points of improvement and address then with the rules, improving the analyzer even more. So now we can see that almost every field was correctly cleaned by our analyzer made with NLP++. This shows the potential of NLP++ to be used as an address cleaner. If you have any questions, feel free to contact me.